Welcome. So today we will be talking about how to classify a salt as an acid or a base. The first thing to understand when it comes to the creation of a salt is the definition of a neutralization reaction. So what is the basic generic form of a neutralization reaction? Well, it is as so. Acid plus base will always yield a salt plus water. So now that we know this generic form of a neutralization reaction, let's take a look at an example of a salt. So say we're given the salt NaCl, and we're trying to find out what is it. Is it an acid or a base? The first thing you immediately want to do is dissolve this salt in water, because we know, according to the generic neutralization reaction definition, that the salt which is created will indeed be dissolved in water. And since it is a reaction which is in equilibrium, we can use the salt we have to work backwards. So we have the salt NaCl plus water, and we're trying to figure out the two reactants, the acid and the base. We're trying to find out which acid and which base created this NaCl and water. So here's a trick to how to do it, and I call it cross multiplication. So we're going to have NaCl over here, and H2O we're going to write it as HOH. So it's obvious that we're grouping. And we're going to literally cross multiply. So we're going to cross multiply over here. You're going to have NaOH. So you have an NaOH. And we're going to do it on the other side too. So you're forming a complete X, and you're going to have HCl. So we have NaOH plus HCl as our reactants, and we know that those are going to yield NaCl, the salt, plus water, the liquid. But how does that help us find out whether NaCl is an acid or a base? Well, first let's classify the two reactants we found as acids or bases, specifically as strong acids or weak acids, or strong bases or weak bases. So let's take a look at NaOH. Now, you should know from your strong base rules that NaOH classifies as a strong base. And since it has OH in it, we obviously know it's a base. Over here, HCl, it has an H in it. We know it's an acid, and we should know from our rules that HCl is classified as a strong acid. Now, you have a strong base, and it's added to an equally strong acid. What do you think the classification of the salt will be? Well, since it's a strong base plus a strong acid, we're going to have a neutral salt. NaCl is going to be neutral because the base is not overriding the acid, and the acid is not overriding the base. Why? Because they're both very strong. Now, let's say we're given a weak base but a strong acid. After we do our cross multiplication, this is what we come up with. Well, the weak base is obviously weaker than the strong acid, so the strong acid will override this weak base. And the strength of this acid is going to lower the pH of the salt. And as the pH of the salt gets lowered, we're going to classify the salt as an acid because it is created from a strong acid. What if we have strong base plus weak acid? Take a minute to try and see if you can figure that out based on the patterns we just talked about. Well, if you said that you're going to have a salt which is a base, you're correct. Because this time, since the base is stronger than the acid, it's going to raise the pH of the salt, which is going to make the salt a base. So basically, a way to remember this is whichever reactant is strong, that is the classification of the salt. But if you have a strong base and a strong acid, which is the example we went over before on the previous slide, you're going to have a neutral salt.